All right, let's look at IceCap Essentials. What is unique about the tool, especially when you're looking at multi-devices from CMOS to 3.5 extractions? Even if you use the tool for years, I want to maybe show you something differently on this river tour that we're on today. The three parts of the pie, measurement, simulation, extraction, and automation, are what comprise the tool. And we have three goals with IceCap team has three goals with the tool: to be productive from day one, to allow you to customize and protect your IP, and to have one platform for measurement, simulation, modeling, extraction for DC to RF. We cover a wide breadth of simulators, all the popular simulators you're going to want to use and need for your work and your customers. The customization's built in. We're going to look a lot at some Python today, for example, and we even have on wafer capabilities in the Wafer Pro tool, measurement tool. And we'll look at toolkits on the next slide. When I talk to my customers and I ask them, why is IceCap such a standalone tool for you? What makes it unique? They tell me these items in red. The turnkey modeling experience, part of the recipe to do the extractions and RF, CMOS, and GaN solutions. The open and flexible environment, all the wide set of simulators that, as I mentioned, the ability to customize with PEL and Python. The optimization tuning on any simulator that you have. IceCap has some powerful features there. The custom graphics and analysis capabilities. And last but not least, measurement solutions. There's a full open source library that you can use directly or customize for controlling DC, CV, RF, high frequency, even nonlinear, linear, nonlinear measurements, probers, different prober controls, and switch matrix drivers. And you can automate the whole thing. Last but not least, just wanted to mention there's some links down here for 5-10 minute videos on common topics to use to get started with IceCap that you might find useful. IceCap covers a wide breadth of models, and I say it's experience is baked in because literally for decades it's been an industry standard tool, and it covers all these different types of bipolar, MOSFETs, gas, diode, power models. I highlighted the ones in red to show you the high frequency RF ones that are very staples with my customers. We cover empirical models, equation-based models like Angelov GaN, physics-based models like ASM-HEMT, and even the new neural network models based on measurement data like ANN that we're going to look at today. If you look at the building blocks of IceCap, it's important to understand there's a hierarchy in that. At the top level, you have the model where you define a circuit, netlist, global scope parameters and scripts and variables. And then you have the next level down is the DUT, the device under test. You describe the general measurement simulation description, DC, CV, RF, linear and nonlinear measurements. You can define a test circuit like a sub-circuit. And you can if you go down to the setups level, which is under the DUTs, you go down to like the IDVG VD-LIN or FGUML under DC. If you go to the setup level, you're defining stimulus and response inputs and outputs. And that's where you can measure and simulate from one spot. I got this subtitle from Manny. I give him all the credit. 6 steps to a better model. It sounds like the old 90s 7-minute abs or something videos that people used to buy. But seriously, IceCap comes down to 6 key steps. You choose the model, step 1. You measure the DC, CV, RF, you extract the model parameters, you simulate, you compare the measured and simulated data, you tune and optimize. And that's the basics. And you can do all this very seamlessly in the new user interface by right mouse button clicking and selecting what you want to do.